Hi everyone. Welcome to the webinar. It's absolutely great to see so many people coming into the room. We're going to start in a few minutes' time, but thank you very much for joining us. I've already listened to this once today, and it's a absolutely fantastic session, and I know you're going to enjoy it and hopefully get a lot from it as well. So just as we head towards the start time for the webinar, I'd just like to let you know that at the end of this session, you'll receive a certificate, and you'll also receive a little booklet with a number of activities for you to do in the classroom with your students or to do at home with your parents. Just want to say that they're all aimed at primary aged children, but if they are but there are a variety of ages in there. So if you ever feel that you want any more content that is aimed at younger children, then please let me know, and I will and we can send some more to you. Right, I'm just moving Debbie, who is our speaker, into the room. Debbie, can you hear me now?
Yes, I can.
Okay, brilliant. Thanks very much indeed. Right, we're on the hour, so I'm going to start. First of all, once again, welcome. Thank you so much for joining this session. As I've said to anyone who had just joined us before, I've heard it once already today. It's a wonderful session, lots of interesting content, and I just really want to introduce Debbie Roberts to you. Deborah has worked with Macmillan for many years, but prior to that, she has a degree in both physics and chemistry. She has a master's in EAL. She's an international trainer. She's a prolific author. She has helped us with primary maths, science, secondary science, and English. And she is so enthusiastic and knowledgeable about everything to do with education. It's always a pleasure to hear from her. So I'm going to leave you in her very capable hands. Do use the chat box because we do like to see comments, and Debbie's very happy to answer your questions, queries, and comment on your thoughts as we go through the session. Thank you all very much. Enjoy the session.
Hi, everyone. I hope you can see me okay because I can't actually see myself, which is unusual, but so long as you can see me, that's all that matters, and hear me, of course. So just follow on from what Amanda just said. Yeah, I love the interaction between teachers and myself. So please, 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 any questions, any comments, use the chat box. It was so nice this morning. So many people commented and asked questions, and it just makes it a nice environment for us all to work in. So welcome to this session, and let's get ready for school. Oh, wouldn't let me share them for a moment. So we're looking at preparing for science to start with. Now, science is all around us, but some students get the impression that for some reason science is particularly difficult and it's hard, and there's some kind of block here in the short-term memory that all this, no, it's too difficult, it's too hard, actually blocks the engagement and the understanding of the real world around them. So we want science to be something that's engaging. We need to increase the curiosity that children have about their world, not our world, not the world that it was when I went to school, their world, what's personal to them and the way that they view it. And the ability and the be able to ask questions. So the content must be real, but real for the student, not real for you particularly. They come first. We don't want them to be passive receivers of knowledge. We don't want them to just be given knowledge. We want them to question it and find out for themselves through hands-on, engaging activities. And most of all, these little people are children. So let's make it fun. Now, I do this and I feel the importance of outdoor learning. I'm very fortunate because I still do actually work in schools. I still see these youngsters in the classroom. So I'm very fortunate that I can gauge what I write and what I plan and what I design for you all to use. I can actually test it out on youngsters. And outdoor learning is extremely important. A few years ago, I was writing a curriculum for pre-primary children, and I observed lots of teachers, lots of experts with their pre-primary children. And I realised the importance of outdoor play. And so I started to research it. And because I spend a lot of time researching and writing, I can pass on to this information to you very, very, very busy teachers. Outdoor learning is fun. It's different. It's not like being in a classroom environment. It's like an adventure. It's completely different. The young people find the outside enthralling, stimulating, and also thought-provoking. Unexpected things happen that we can quickly and expertly link back in to the content of the lesson. For example, seasons. Schools can be outdoor and we can experience, especially in the UK, the north of the UK where I live, we can experience all of the seasons in what seems like one day. It changes, the weather changes, and from season to season they can experience that. We should extend our play, our outdoor play and outdoor learning opportunities as much as we possibly can. But the most recent research shows that children thrive academically if they have a minimum, at least 3 hours of their day should be spent outside. And you won't be surprised to know that the best time is in the morning. Morning is the best time for children to learn, for all of us to learn. Some of us change slightly as we get older, but in the morning, our brains are more perceptive. They're not as confused by everyday events. The short-term memory doesn't get all blocked up. And so it is more advantageous. So hi from Lebanon, Oman. Hi, Sana. You love about science. It's hands-on. Yep, and using the real world around us as our resources. You'll soon realise by the end of this webinar that I don't spend money on resources. What I enjoy the most is being able to use readily available materials to teach and have an hands-on experience. Lots of reasons for that. One reason is if you start collecting recyclable materials, for example, or sometimes plastics and things like that that can't be recycled and just end up in landfill. If you can plan to use these, it's an endless resource, which means that all the children can engage in the activity. Not once, but if they want to repeat it, the materials are endless. They can repeat their investigations, their experiments, their activities, and they're not restricted by limited equipment or expensive equipment. So some of the content from the curricula is listed here. Plants, ecosystems, forces, structures, day and night, the moon, weather, water, air, animals, sensors, and on it goes. How can we teach all this? Some teachers come up to me and it's only a third of the way through the academic year, and they tell me that I've taught all of the curriculum. And my response to that is always, and how much have they learned? Because, unfortunately, not unfortunately, when we design curricula, we have to make sure that we've covered what all schools teach. We also have to ensure that some schools might teach more lessons of science in a week than others. So we have to accommodate for all of them. The chances of you being able to teach the whole of the curriculum is limited because of that. Being able to teach it traditionally with the teacher stood at the front of the class and students being passive receivers of knowledge is impossible, I'd say. So we teach it from an inquiry-based approach where we're developing skills and we're training young people to educate themselves, to be so interested and to be so confident and skilled that they want to find the answers. Go outside, use the outdoors as your tool and your resource to teach the curriculum. This is a young man that is very keen on Macmillan, as you can see, promoting it for us there. He's my grandson and he understands the importance of promoting Macmillan education. Here we are on what we call a welly walk, and I do this with all the children that I work with. It's just that he was there that day and tagged along. We call it a welly walk because it often is muddy and rainy where I live, and it doesn't stop us. We just get our boots on and our raincoats and off we go. All we need is a bag, any bag. It's just that he likes that little fabric tote bag. And what we do is we collect things in nature that we think are important, and we have conversations about the importance of their findings. Here he is with a rather large leaf, looking at it with his Macmillan hand lens. We can compare the changes in the weather by just being outside. We don't have to explain this is a symbol for the sunshine or this is a symbol for a cloudy, rainy day. We can actually experience it. We can look around and talk about, is it cold? Is it hot? Is it warm? Is it windy? Is it sunny? Cloudy? All these different key words and key vocabulary just coming into our experience of being outside. And then we can start to think about, so how have the living things changed or adapted to be able to live in this ever-changing weather? We can listen. What can we hear? Can we hear the weather? Well, we can hear the wind. We can hear the branches creaking and cracking. We can hear the leaves rustling on the floor. We can hear water running. So we're using the environment to teach about the weather. And then with our things that we've collected, what can we do with them? What can we make with it? So we talk about it, we record it, we find it, we keep it, if possible. We can't always take things from nature, but often we can. And then we make something with it. And then we talk about, well, some plants and animals like to live together or do live together quite well. Why didn't the insects live in the middle of the path? One of the students asked me. Why do they hide under the leaves? So we talked about predators and prey and being protected. Living in the middle of the path would not be sensible because you 15 4-year-olds and 5-year-olds would have just trampled all over them. We went to pick some berries. We liked the colours. But we noticed that some of them had got sharp, spiky bits or thorns. Why would that be? To protect the berries, because the berries include the seeds and we want the seeds to be planted and to grow again next year. Then we talked about why some plants have flowers. Some of the leaves were just leaves on a plant without any flowers, but some were beautiful flowers. And then someone asked about why the bird poo was red. And so we talked about food chains and digestion and the idea that maybe the insect ate some of the berry or maybe the bird ate some of the berry. And look how it's made our fingers go red and purple. That's maybe why the poo was that colour. And children particularly like to talk about things like that. But if it makes it memorable, it's worth it. And then the water, the air and water. So the water bit is just good fun. So we jumped in the puddles. We talked about why we need water. Why is the water so much fun? Why do other living things need water? What do we use water for? We decided that we washed in it, we drank it, we cook with it, we bathed in it, we swam in it, and we jumped up and down in it and got really, really wet. We breathed in the air. And one of the children said, air doesn't weigh anything. Okay, so why doesn't it weigh anything? Why doesn't it have mass? Well, it can't do, because you've just told me that the air's all around us. And if it is, why can't I feel it pressing on my skin? Why doesn't it push my head or my hands? And so we said, well, if it exists, it must weigh, it must have mass, okay? And if it does, it must weigh something. But what do we do with this air all around us? Why is it so important? We talked about breathing and put our hand in front of our face, and we felt the air sucking in and being breathed out. We talked about when it was breathed out, it was warmer than the air around us. And then we put our hands on our chest and we felt our chest rise and fall. And we talked about how our lungs filled up with air. And so our chest moved to accommodate the expanded lungs. And then someone said, so what is wind? Now, how much science have we just discussed? And we've walked a couple of steps outside. We used our senses a lot, and we used the opportunity to link what we were doing outside with our senses. So we looked at the weather, we looked up at the sky, at the clouds, at the sun, the different coloured clouds. We looked at the pretty flowers, the green plants, and any insects and animals that we found. We smelled the flowers, and we realised that some flowers had a really strong scent, and others had such a mild scent that we could barely smell it. We picked up a handful of the soil, and we smelt the soil. We smelt the stones that we collected and the berries, and we even smelt the puddles. And we realised that lots of things that we didn't think would have a scent actually did. And we talked about why some things have a scent, to attract something or to scare something else away. We listened, we stood quietly in a line, and we all didn't say anything, and we just listened. And then we talked about what we'd heard, and the children reported a dog barking in the distance, some road traffic passing by, and lots of birds singing. And we talked about, are the birds singing the same song? And we realised they were all different pitch, different volume, and some were close and some were further away. We touched all the items that we collected. And this is the importance of actually physically picking things up and exploring and observing, and then if possible, collecting. Now, we don't need to collect things that would spoil the habitat. So any plants or flowers or animals shouldn't really be removed if they're living, but if they've fallen off the plant, that's fine. And then we used lots of paint and glue when we got back. We made collages of what we'd collected. And so we actually not only touched them, but we also smelt the paint and smelt the glue. And then we made a pie out of the berries. And we did lots of maths and lots of science when we made that pie, but we tasted it, and that was the fun bit. All the things that we collected, which were a huge array, not just natural products, but other products too, we decided that we'd sort them into groups. We allowed the children to sort them, to choose whatever grouping method that they wanted to. But some we differentiated and we gave them an idea. Is it wood? Is it plastic, metal, glass, paper? And we also remembered that some of the wood was actually once living and was once a plant. So we talked about how it might have become the wood in the items that we'd collected. If you are collecting things, be very careful. I planted some of the things that they could collect, so I knew it was safe and clean. We were able to talk about day and night on that one walk as well, because the length of day and night changes here in the UK, and so we were able to see daylight in the morning and during the time that they first started at school, And then later on in the afternoon, it started to go dark. I asked them, what's the difference between day and night? What's day like? What's night like? What's the main difference? And the answer I got was, it's not sunny. So the difference between day and night and dark and light is the absence of light. So when it's dark, it's because there isn't any light. And when it's light, it's because we have natural sunlight. What changes at day and night? Ask the children, what do you do in the day? What do you do at night? What's different? What's the same? Compare the things that we do differently. We might have our dinner in the evening, and we might have a bath or a shower and go to bed. We might have a story and a snack. And in the morning, we might get up and have our breakfast and get ready for school. But don't just talk about yourselves, talk about other animals and plants as well. Do all animals and plants go to bed at night time? And the answer to that is no. Anybody got any questions so far? The chat's gone very quiet. I feel alone. But we can talk about how some animals come out at night because they can maybe find more food or hide food. They might feel safer because they can hide in the darkness, in the shadows. And others are better in the daytime because it's brighter and sunny and they can see if there are any predators. And one of the differences between day and night is it goes dark. But most of us are very fortunate because we have something called electricity. And if we don't have electricity, we might have had candles or lamps so that we can see even when the sun goes down. And one of the children asked me what electricity is. What is it? And we said it's a form of energy that lights the light bulbs so that we're so lucky that when it goes dark, we can press a switch and we have light. And so we can do things at night time and in the darkness because we have electricity or other sources of light. But the main form of energy that we have on Earth is our beautiful sun. And though it's miles and kilometers away from Earth, it's so far away that we still can get our skin burnt because of the intensity of that energy when the sun's really hot and up in the sky and clear. Also, we get heat from the sun and that can burn our skin with the UV and the different wavelengths. We wouldn't go into that with this age group, but even so, we can feel the heat. We get hot, we get warm when it's sunny, and heat is another form of energy. So the sun gives us light, and if light's energy, that means colour's energy too. So we can talk about the different colours of the spectrum. And if you are on a welly walk and there are some puddles around or some natural sources of water, we might see a rainbow, a whole spectrum of colour being broken up, all the colour from the white light we see from the sun. Of course, we need to make sure that all children understand that our main source of energy on this earth is the sun, and without it, we wouldn't have any plants, and therefore we wouldn't have the start of our food chain. So energy can also make things move. It can't just heat us up or give us electricity. It can make things move. And it's really good fun to make windmills. They are a little bit tricky sometimes, depends which one you follow. But they are good fun to make, and especially if it's a breezy or windy day, you can have great fun, or you can just blow them and reinforce that breathing out, how your lungs are holding that air. And you can use that to blow a windmill or blow up a balloon. Making catapults is good fun, maybe out of one of the twigs that you might have found. And again, we can talk about elasticity and how elastic energy, how we can stretch it and how we can make it move things. And of course, clockwork or wind-up toys are always good fun for this age group. So now we can think about preparing for maths, but the most important thing here is the massive link between maths and science. For me, maths and science is the same science. It's the same thing. Without maths, we can't really study science in great detail. And without science, we can't really explain a lot of maths. So you'll see here, this is identical to the slide about preparing for science. Maths is all around us. It shouldn't be feared. Too many times we hear children saying that maths and science is too hard. How can a child of this age know that maths and science is hard? How can they possibly know that? They've experienced it from somewhere, and someone has maybe unconsciously said that it's maths, it's hard, it's difficult. I don't know why people get the impression that it's difficult, because it's around us all of the time and we have access to it all of our waking lives. So we want to increase the curiosity about the world around us using maths. Again, the content must be real. It has to be meaningful for the children. Know your children. Find out what they're interested in, what they like, what they dislike, and use that to design the content for them in their world. And it's always got to be hands-on. And again, like I said earlier, if you use materials that you've recycled, that you've found, that you've collected, then it makes it a much more effective hands-on experience. You don't have to worry about the materials that are available because you're recycling or you're collecting. They're free. You're actually doing the environment a favour sometimes by using them, because as I said, they'd end up in landfill or the ocean on a sad day. But whatever you do, make it fun. Make it fun, and then they will be engaged and interested. So we made a pie. Great. Where's the maths in that? Well, we collected the berries and we tried to estimate if we'd collected enough. Is this enough to make a pie? How much do you need to make a pie? I don't know. We counted the eggs, we measured the flour, we measured the butter. I allowed them to do it for themselves with support. They did not watch or observe me or the teacher or the other adults in the room. They did it for themselves. They worked it out for themselves. We just supported them to make sure their pie was successful. And you can see here that we've made a pie case, we've filled it up with the berries. We did put some sugar in there, they were quite sour. And now we're just rolling out the pastry to make the lid. The picture of the teddy is because in the class, the children adopt the teddy for a day and they take pictures of themselves doing interesting things with the teddy, and then they show it to the rest of the class the following day, and then we talk about their experiences in the real world, how they actually lived their lives, what they did, but the photographs are what they found interesting. And here this student found the making of the pie extremely interesting. I don't know whether that was the actual making, collecting the berries, making it or eating it, but anyway. So here we are making the pie. I think if I click on it again, it does show the video, which I did intend to just show you the picture, but at least you can see that he did it himself and I didn't do it for him. It's very hard work, you know. There we are. And this is what we collected. Allow the students to display their collections, their treasures, is what we call them, how they display their treasures, how they organise their treasures. Talk about the size. Some of them organised their treasures into whether it was red, yellow, green, whether it was bigger, smaller, whether it was alive, the twig, whether it was a piece of wood or if it was dead. As you can see, particularly like to collect stones, So they were also organised into different categories as well. And then someone, even at this very early age, said, I've organised my treasures. Here's my display. And it was living and non-living. How good is that? Living and non-living at this age is quite phenomenal, but it just shows what a trip out into the outdoor surrounding spaces can do. And you know, even if you're in suburbia, you can find some things that you'd be amazed at, and the children are amazed at. And it'll vary from country to country, place to place, but that's the beauty of it. So here we go. Maths in year 1, taken from curriculum for year 1. So what have we got? Numbers and counting, shapes, time, exploring numbers, addition, subtraction, patterns and number, counting, estimating, multiplication, division, and handling data. Phew! So how on earth can we teach all this as well as everything else? And I have had this dilemma. I run a network for pre-primary and primary school teachers who I know are so talented and gifted that they have to teach everything. And it's often different things going on in the classroom at the same time. So it takes a great deal of planning and a great deal of classroom management also. As I said, I'm an inquiry-based teaching and learning. Some people say an expert, but practitioner. Everything I've ever written, everything I've ever taught, I've always used this technique, always will do. I'm passionate about it. I'm passionate about it because I see the effect it has on children, their progress that they make, their confidence grows, their skill set grow. And it's not only a skill set to be used in one subject area, it's cross-curricular, but even better than that, it's lifelong. So we can get through curriculum by using EBTL. I've done lots of things on this, but basically this session is inquiry-based teaching and learning. It's hands-on, minds-on, skills-based, questions-based learning. So it lends itself beautifully to maths and science. So how can we sort and group? When we need to look at shape, we know that shape's important in maths, especially early maths. You can go out and buy lots of expensive things, but remember, if it's a hands-on experience, they'll understand it better and they'll also remember it better. So if it's hands-on, the reason that they remember it more effectively is because it's a slower process. If they're observing a teacher threading these elastic bands around these pegs on this board, it won't take very long. It's like when I'm building flat pack furniture. If somebody comes along and says, well, you do it like this, I will never remember that. But if somebody gives me the instruction book and I've got the pieces and I've got to sort them out and I've got to sort the right screw for the right hole and I've got to use the screwdriver to attach it, I'll probably remember. And most students learn in a similar way. So we've got the pegs, the elastic bands, you can use thread, you can actually use the plastic, you can purchase those, or fabric, that have got holes in, give them a big plastic needle and allow them to actually sew the different shapes. Or just quite simply, get the building bricks out. Talk about the different shapes, triangle, rectangle, semicircle, circle, and allow them to build and actually explore and hold the bricks, feel the corners, feel the round edges on the circles, feel the square edges on the squares, the triangles and the rectangles. Let them experience shape, and then they'll be able to group the shapes and group different items into their own groups. And as in science, It doesn't matter what groups they choose, as long as they can explain why they're using that grouping technique and how it actually worked. It doesn't matter what their groups are. And then allow them to share their groups with other people. Why did you do that? I did it this way because. Yeah, but I did it this way because. Some of our students may be learning science and maths and English as an additional language. That's a challenge, but it's very doable. So if your student says something to you like triangle, not triangle, don't correct them. Model it. So if they said to you, could you pass me that triangle block? Say, do you mean this triangle? Do you want this triangle? I'll pass that to you. There's your triangle. You're modeling pronunciation. You're not actually correcting them. If you correct students who are learning a language, they will stop speaking. Their confidence will vanish before your very, very eyes. But is it important that they pronounce words correctly? I'm afraid it is, because the research tells us that if students continuously mispronounce words, especially keywords in science and maths, and the strange language that English is, they probably won't be able to spell it correctly. And as they progress through their education, some of the research says and states quite clearly, and there is a lot of data and data analysis on this, they cannot progress beyond a certain level. So they may well be very bright and they may well seem to be good communicators, but if the pronunciation is not good, by the time they're going on to maybe secondary education, then they can only probably progress as far as an admin worker or something like that, which is great, but they can't be a teacher like you or myself or a university lecturer, because the pronunciation actually hinders their progress. And that, I'm afraid, is a well-researched fact. You might be thinking, I'm teaching really, really young children here. I'm teaching school starters. But if we start as we mean to go on, it means every year they make more and more and more progress. Have we got any questions? Would anybody like to share anything? Any questions so far? Any experience of this in your classroom? No? Please feel free to use the chat box if you want to. Okay, 1, 2, 3, 4, 5. How many times parents tell me that my son can count to 10, my daughter can count to 15, and I hold up 5 fingers. How many fingers is that? 9, 7, 11, 4. Learning to count, rote learning, doesn't work, but action does. It most definitely does. The hands-on action works, and the messier it is, the better. Here you can see students using the small pom-poms that you're using in crafts. Okay, they love them, the different colours. Some of them are glittery, some of them are big, small. Using the forceps, we're using fine motor skills, so we're promoting that, which helps students hold a pencil, which helps them to write better. So it's all interconnected at this age. We can use the forceps and look at the drawn sorting circles on that piece of paper, or we can use the cups. Use these pom-poms and the forceps. What's 3 add 1? Count 1, 2, 3 pom-poms, and then another one. How many have you got? 4. Make that one even more interesting. Use a drinking straw. Make sure none of your students have got respiratory issues, but they love doing this, especially if you make it into a competition. Give them a straw, get some cards with numbers on, or post-it notes, pieces of scrap paper with random numbers. They turn one over, take it in turns to turn over, and then they've got to suck up how many pom-poms they've seen on the post-it note. Great fun, great competition, and cheap as chips. Just make sure they don't use the same straw, and make sure we don't have respiratory issues, of course, or just use the forceps. Doing the 1, 2, 3, 4, making the different body segments for this caterpillar is also good fun. It's squishy, they're using the senses, they're feeling the paint, they're feeling the paper. So rather than just counting 1, 2, 3, 4, they're actually experiencing what 1, 2, 3, 4 is. Every dot is an experience. 1, 2, rather than just counting. Rote learning doesn't work. Remember the stick that was on the display? We used it to count. You notice that my maths lesson wasn't a maths lesson or a science lesson. It was maths and science. It's cleverly looking for links. It's not that clever, otherwise I won't be able to do it. But it's just taking opportunities. So the stick then became the counting stick. So every step, we took a step, one step. But every time we took the step, we hit the ground with the stick. So we felt the count. We felt it in our feet. We felt it in the stick as it hit the ground. We heard the sound. It was good fun. We were all walking along going 1, click, 2, click, 3, click. What an experience. Making a noise while counting works. It just does. When you take the objects back to the classroom, like the stones, some of the hard berries, get a tin tray, a baking tray, an old tin can. It doesn't really matter as long as it's safe. Get the students to drop the stones onto the tray so it makes that noise. As long as it's metal, it's safe and it makes a really good noise. So it's 1, clang, 2, clang. The noise, the experience of that number of stones, the counting and the noise just supports their learning, makes the counting make sense. It's meaningful. Which number is between is a good fun game that we can just, you could just write your number sequences anywhere and ask the question, what number's between? Doesn't really matter if they get it wrong or right. It's that discussion together of, well, I think it's 7 because 6 and 7, and then you've got 8 and 9. Oh, I don't, I think it's 8. It's the discussions, the chat about what they think. And can you see that they're using the numbers? They're showing that they're understanding, they're analysing the numbers. Using number tracks are also really good. Sometimes that student that comes into your class, which often at this age, young children don't know what maths is. They don't know what addition is. Someone's told them that it's difficult. We have to unpick that, okay? And so their confidence might be low. And they'll sit there and not really want to engage. And when you're sat counting with them and you ask them a question, you can see they're thinking, but they don't want to give an answer because they don't want to get it wrong. They just don't want to get anything wrong. Children want to please their teacher. They want to please their parents, the people they live with. And so if they're not very confident, they'll tend to say nothing. And the longer it goes on, the quieter they become. Using strategies like the number track actually promotes their confidence. It gives them an opportunity to very easily check their answer. And suddenly, when they say, well, I think that 0 plus 6 is 6. I'm not sure. I'll check it on my number track. Oh, yeah, I think I'm right. And then someone gives the answer, 0 plus 6 is 6. Gives them the confidence. So when it comes to the next question, they might offer an answer quicker and be more engaged and more involved. I don't have a hands up policy in my classroom. My classroom is a no hands policy. We have different ways of asking and answering questions. So it is a little bit of fun. But when you're sat with a student, you really, really do want them to be able to give you. How do I assess individual student? Right. Do you know what? I actually wrote a paper on this. It's a really, really exciting question that you've just asked me there. Because I'm an inquiry-based teaching and learning practitioner, most of my time goes into the planning of activities and lessons, not in the delivering of it. I don't stand at the front. I will sit with a group of students. So I make sure every day I have sat with a student at some point. It's usually in little groups of 4. And you're asking questions, you're listening to their answers, you're listening to their questions and their ideas about the answers between each other. So assessment is first time assessment. So my students don't walk out of the classroom and wait for a book to be marked or something like that. If I've told them what the learning objective, today we want to learn about addition up to number 10. And I go and I walk around the room and I listen and I look at what they're doing, I can say to them, well done. You've achieved that. You've done that already. Well done. Now let's see if you can go to 12. If you get what I'm saying. So it's first-hand feedback. So that assessment is live assessment. And that student knows immediately, I can do this. I'm confident. I can move on. Great question. Thank you. And then we can use that once they've got the confidence. Guess what? We can use it for subtraction. What is it? Simple. It could just be a piece of paper with the numbers written on it. Get some wallpaper out. You know the backing wallpaper that's on a big long roll? Roll it outside. Put a stone on one end and a stone on the other and make the biggest one and get them to jump between. Okay, rather than just going like that, let's jump 3, 1, 2, 3. Now let's go back to what number have we got? What's the answer? Let's write that down. And now we're learning how to write the numbers as well, and we're experiencing the numbers. Even and odd numbers, love this, always will do. Roll the dice. Is it odd? Is it even? How do you know? Well, if I can split it in 2, it's even. And if I can't, it's not. It's that simple. Use things that are familiar to the children, that the children love, okay? And if you can make it into a competition, do it. Because in maths and science and all learning of all ages, we all like a competition and we all like to win. And so when we're given the answers, okay, how many teddies are on that shelf? 5, 6, 9, 11, 4. I'd like to think that they'd all eventually get to 6, but there you go. Prove it. How do you know? 1, 2, 3, 4, 5, 6. Correct. Someone might say, no, I disagree, because one teddy's smaller. So I actually think there's only 4 or there's only 3. How do you know that? Encourage an argument. Okay, you might call it a discussion, or you might call it just some dialogue or something like that. I like a good argument, because you get children arguing about the content of your lesson, not about horrible things, about the content of the lesson. They have to use the key vocabulary correctly. They have to have a good idea about the content of the lesson in order to just be able to argue. So if your class is arguing all day about number or big, small, round, square, fantastic, because they're not just arguing about that one thing. They are using all their knowledge that they've picked up to win the argument. And I've seen this happening with adults, with children of all ages, and there isn't even a prize. It's just the sheer will to win. Start collecting jars, people, of all sizes and shapes. I love these activities, especially if it's candy, and they know that at the end, once in a while, you just might allow them to eat some of the candy if they keep getting it right, or if just using good mathematical skills. And get them to estimate, how many do you think are actually in there? Why do you think that? Because. Okay. Count them. Are you right? Are you wrong? I would write on the lid of the jar. Make sure the jars have lids and they fit properly. We don't want them, eating all the sweets and being unwell. Make sure they fit properly. And I always write the number on the top, so it's actually the number 1. And then underneath, an opportunity to actually link that to the word 1. In that way, they're learning 1, drop the candy, that's 1. 2, and they're also learning that in maths, we also can write the numbers as well. So get them linking the written word with the number and the actual physical number of objects. I also love this as a competition. How big do you think it is? This one's the biggest. No, that one's the smallest. I think this one's the shorter. This one's the longer. They're using all the vocabulary. Well, how can we prove it then? Because I don't know who's right. What could we use? Watch them use a ruler when they think they'll win an argument. It really, they become extremely accurate at using all measuring equipment if it's a competition. Days of the week can be really difficult. I encourage children to think about something that really is important to them or that they really enjoy. So it can be a diary. So last Monday, I really enjoyed it. We went swimming. On Sunday, we went out for, I don't know, tea. We went for a walk on Saturday, and they can draw a picture. You could encourage them to take photographs maybe at home and do it like a home learning activity as well. Or it could just be like a timetable. On Mondays, we do cooking. On a Thursday, we play football, soccer, tennis, doesn't really matter. So long as they can link it to a real experience, they will soon learn the days of the week. But telling time is another one. Using things like this, just simple, easy devices where they can actually feel I can't remember the word. They can actually feel the dials on the clock. They can put the numbers into the different shapes. It's colourful, it's interesting, it's engaging, and talk about what you did at certain times of the day. The problem is they've got the 24-hour clock and the old-fashioned clock. Here we're using sensors. What sensors are they actually using in these activities? Well, they're touching the things, they're feeling them, they're looking at them. And if we're using glue, they're using the sense of smell as well. I'm glad you're enjoying that, Manuel. I hope you can use them in the classroom. Great to see some pictures of your students using things. And here we go. I love a game. I think these are called fly swatters or something. So I use them for all sorts in the classroom. Just get a piece of paper or post-it note stuck on the wall with a number, roll the dice, splat the number. And if you want them, if you're pushing them to be able to spell the numbers as well, have some written, some numbers, and then when they can do either one really, really well, just have one. Keep mixing it up, changing it around. Doesn't have to be a dice. You could use your little jars that have got the number of objects in. They pick an object up, they look at it, they splat the number. They can take turns doing it. They can just play it by themselves. It's great fun. I've seen adults playing similar things to this, just using the swats. I bought one, I can't remember where it was. It was so cheap. And when I got it, when I opened it, it was in a pack of 3. I was so excited. So here we are, the hand lens. You might have noticed on other pictures that sometimes the hand lens is the wrong way around, but we talked about what it does. How does it actually help us? How is it different looking through the lens? Oh, it looked bigger, it looked smaller, big, small, bigger, smaller. It's all the key vocabulary from a simple conversation. We'd lost the baby that had tugged along in the pushchair there, was actually sat eating some berries. But there you go. Here we go, shadows. Just using chalk and kids measuring the shadows. Measured the shadow at the start, the height of the person at the start, the height of the shadow. We asked them to predict, will your shadow be the same size as you? Yes, of course it will. I don't change size, do I? Is the answer I got. But then they realised after a full day of measuring their shadow, it actually changed. So we were able to talk about the position of the sun in the sky and why the position of the sun in the sky actually made a difference to the size of their shadow. Some really, really good science in there and really good maths, measuring, talking about why the time of day changes their shadow. I was told that in some countries, it's actually not a great idea to walk on the sidewalk, to draw on the sidewalk. We're using chalk. So just wash it off. Or use a stone, a natural product. This young man said he was Superman because look at him. He's flying above the buildings. And we wanted to know where the maths was in that. And would you believe it? He started to tell me about scale. The buildings were not to the same scale as him. So he looks much bigger than the actual buildings. Talking about scale at that age, phenomenal. Okay, I think I've got through everything. The problem is I could talk about maths and science all day long, if I'm honest. So making me try to cover it all in an hour is a challenge, but I enjoyed it. So I hope you did. If you've got any questions at all, please feel free to use the chat box and I'll endeavour to answer everything. Thank you so much for the people that have asked questions already. And thank you so much for those that have made some comments, some lovely comments there. I'm really, really pleased. Makes it all worthwhile. So thank you very much for your time. And I guess I should pass over to Macmillan to end this wonderful session. Thank you so much for spending your time with me just now. And I hope to see you soon.
Thank you, Debbie, very much indeed. That was, as ever, really interesting. I think the things that I've taken from that are the link between maths and science and the importance of hands-on, you know, how that really helps. That sort of sensory learning is really important. Thank you all very much for attending. You will receive a certificate and a booklet of activities after this. If you want to see more resources that can help you support your parents, then please go to macmillanic.com, which is our website, and there are lots of resources there to help you. Thanks again, Debbie, and thank you to everybody who joined us. Thank you for your lovely comments, Debbie, very much deserved.
Thank you very much.
I'm going to close down the website now. Thank you very much. Bye-bye.